Hello and welcome to this tutorial. We are going to look at IP addressing. This is our first introduction, part 1 to IP addressing. And IP addressing is probably one of the most important aspects of being a network administrator and understanding networking. And it's certainly a very important topic on the CCENT and the CCNA tracks. It comes up quite a lot. So this means you really have to know your IP addressing. Not only the format of IPs, but grouping concepts and subnetting. There's a lot to learn, and there is some math involved. But don't get too discouraged. The math is pretty basic. So my suggestion is practice IP addressing every day until you are very comfortable with it. Even when you're moving on to different sections of the study track, include at least one IP addressing exercise every day. You should be able, at the end, to solve any IP addressing problem in about 15 seconds. And you can get there and you can do it. So, with that said, let's begin. And we're going to talk about the basics first. What is an IP address? Let's get that out of the way, and then we'll look at the purpose of it. It's pretty straightforward. And then we're going to look at two versions, IP version 4 and IP version 6. Both of these come up, and you, as a professional, will definitely be dealing with both of these. And then we're actually going to get into the fundamental building blocks of an IP address. These are the basics, bits and bytes. And we'll look at how we can express an IP address in two different formats, the decimal version and the binary version. All right, so here we go. So what is an IP address? Well, quite simply, it's just a number, and that number is used to identify a device on a network. And once a device has an IP address, it's commonly called an IP host, because quite simply it's hosting an IP address, and that address is used to identify it. And IP addresses are configured in software. Now this is different than what we learned about MAC addresses, because a MAC address is burned in on the actual hardware and you can't change it. Well, IP addresses can be changed, they can be placed and removed from a device and moved around, okay? So they're configured in software. And what's the purpose of an IP address? Well, that's pretty simple as well. IP addresses enable hosts to communicate across networks. So if you want to talk to somebody, you need to have an IP address and they need to have an IP address. And if you know each other's IP addresses, then you can send and receive information to each other. In fact, if you want to use TCP/IP, then you must have an IP address. It's a requirement. There are two versions of IP addresses. One that has been around for a while, which is IP version 4, and the new one is IP version 6. Now new, it's been around for a while as well, but it's only recently that it's been actually gaining popularity and actually being used. And we'll figure out the reason why in just a second. So IP version 4, IP stands for Internet Protocol. This is part of the TCP/IP protocol suite, was the first version to really take off. And at the time, the approximately 4.3 billion IP addresses available seemed like that was enough. But the Internet has grown significantly, and IP version 4 is nearly exhausted, meaning it's been allocated to pretty much everybody, and there's no more left. We've run out of IP version 4 IP addresses. So that introduces us to IP version 6. Now, this is a newer version of IP, and it's meant to succeed version 4. But version 4 is not going to disappear. Version 4 will be in use for quite some time. We're just going to now, you're going to start seeing more and more IP version 6 alongside IP version 4. There are some differences. IP version 6 has a different format to it, and it has significantly more IP addresses available to it. In fact, it's 2 to the power of 128. So if you were to calculate that number, you can see it's enormous. Now, IP version 6 is not really covered in the CCENT track. It mainly comes up when you're going for the CCNA. So we're not going to touch too much on it here, but if you are going for the CCNA, we do cover this more in some of those tutorials. Alright, let's talk bits and bytes. These are some of the basic components of an IP address. So first, a bit. Well, a bit is either a 1 or a 0. It's just a number. And if you were to gather 8 bits together, then you have a byte. Sometimes a byte is referred to as an octet. It doesn't matter which one you use, they refer to the same thing. It's just a grouping of bits. Now, an IP address is made up of 32 bits, so it's pretty big, and obviously a byte equals 8 bits, so you can also express an IP address as 4 bytes, because each byte is equal to 8 bits. So we have a couple options available to us when we want to express an IP address. First, there's the decimal approach, commonly referred to as the dotted decimal notation. And that's the one you're going to see day in and day out. It is the one you'll see 99% of the time. The other method is the binary method. And that's not very practical to use on a day-to-day basis, but we're going to go over it a few times because it's very helpful in aiding us in really understanding everything there is to know about an IP address. Now, there's one other method. You can express an IP address in hexadecimal, but that doesn't come up too often, or rather at all, in IP version 4 on routers and switches. It does come up in IP version 6, so for now we're not going to talk hexadecimal. All right? So let's begin by looking at binary. We have 32 bits listed here, so that's an IP address. And if we want to group these into bytes, in other words, into groups of 8, we could do that, and it would look something like this. So we have 4 bytes there. However, when we talk IP addressing, people usually don't say bytes. They usually use the equivalent term octet. And this is important to note here because the octets are numbered in an IP address. It begins with 1, 2, 3, and 4. So an IP address is made up of 4 octets. Each octet has 8 bits in it. So for a total of 32 bits. That's this is the structure of an IP address, so commit these terms to memory, okay? However, using binary, like I mentioned, isn't very practical. Trying to tell somebody this IP address in binary, it's not practical, it wouldn't work out very well. So the next approach we can use is the dotted decimal notation. And so we've expressed this 32-bit IP address in dotted decimal right here. 10.10.10.1. So first of all, it's called dotted decimal notation. We're using decimal, we're using numbers here, and the dots are just decimal points between each octet. Okay, so you can see on the bottom here, we also have 4 octets. 1, 2, 3, and 4. They match the binary version. Okay? Now, in binary, if we were to take these 8 bits, which is 1 byte, our first octet, well, they represent a value. That value is the number 10. Now, octets 2 and 3, coincidentally, in this example, are the same, so they also represent 10. Finally, our 4th octet, the number is 1, and it's represented down here. That value in binary here is 1. Okay, so you can see the decimal approach, the dotted decimal notation, is very simple. You can grasp the value of each octet immediately, whereas in binary you have to look at it and you have to know your binary to decimal conversion pretty quickly in order to figure that out. So obviously decimal is the most commonly used format. Each octet can be a range of numbers, and that range is 0 to a maximum of 255. Alright, so these are the basic elements and format of an IP address. We have octets, and then we have the dotted decimal notation, and then each octet can have a minimum and maximum value or something in between, and that's 0 and 255. So get familiar with these terms and commit to memory this structure of 4 octets with 8 bits in each octet, and we express that using decimal. Okay? And congratulations, because you've just made it to the end of your first IP addressing tutorial. This is a great start, and we'll be able to build upon this foundation with each successive video. So to summarize, Study IP addressing every day. Do not shortchange yourself here. You need to know this stuff cold, in and out, without any delay, okay? And you can do it. It's simple. It just takes practice. IP addresses, we know they identify devices and enable devices to communicate across networks. We talked about the two different versions of IP addresses, and we know why IP version 6 has been introduced. And then getting into the format and makeup of IP addresses, we know there are 32 bits and 8 bits make up 1 byte or an octet. So that means an IP address has 4 octets. And starting from the left, it's 1, 2, 3, and 4. Know those placements. It's important because people will reference certain octets and you'll need to know which one they're talking about. And then we talked a little bit about the dotted decimal notation and how it's just so much easier to use than binary. And we know that each octet has a value, and that value can fall anywhere in a range of 0 all the way up to a maximum of 255. Okay, so that's it. Thanks for watching, and study IP addressing every day.